in user mode API hooks and bypasses. I'd like to thank our guest speaker tonight, Magnus Stubman. He'll have an introduction in a little bit of time here. Just briefly, I wanted to tell you a little about OWASP, and I hope that all of you guys will sign up and join. So OWASP Web Application Security Project is a nonprofit organization, foundation, improving the security of software through community-led open source software projects, and with over 200 local chapters worldwide, tens of thousands of members, and leading educational and training conferences, the OWASP Foundation is the source for developers and technologists to secure the web. Annually, about 7 million technologists and developers visit OWASP.org. OWASP is a worldwide free and open community focused on improving the security of application software, and our mission is to make application security visible so that people and organizations can make informed decisions about application security risks. Everyone is free to participate in OWASP. I hope all of you guys will join, hint, hint. And all of our materials are available under a free and open source open software license. All OWASP events except conferences are free to attend by both members and non-members of OWASP, and can be attended by anyone who is interested in application security and cybersecurity in general. The OWASP Foundation is a global not-for-profit charitable organization. It's a vendor-neutral community. It relies on the collective wisdom of the best minds in application security worldwide. It provides free tools, guidance, and documentation. Meetings are free to attend, as you know already, as I just mentioned, and sometimes free drinks and food are included when meeting in person, which of course is not allowed right now because of COVID, but in the future you might get some nice drinks and food. Meetings are usually 2-hour seminars, usually 2-man talks with optional lightning talks. There are 207 local chapters in 56 countries and growing every day. 189 projects, including 20 flagship projects. And we have 2 chapters in Denmark, Aarhus and Copenhagen. Please again, join one of them. And everybody's a volunteer. So our chapter president is Alessandro. We have some great volunteers, Andrada, Dakota, Jens, Josefina, and myself. And I hope that we'll see some of you in the future. And if you want to contribute, volunteer at our chapter, or if you want to do a talk or a workshop or something else, and of course, participate in events like these. You can also join our mailing list, which you can we'll supply to you at the end of this talk. And without further ado, if you have any questions, of course, feel free to ask the speakers during the talk, but I'll turn it over to Magnus.
Thank you, Geoff. Okay, so first of all, thank you for giving me the chance to speak. One of the reasons that I chose to present today was that I'd really like to get some feedback on the things that I've been working on, and these thoughts and ideas and methods and tactics that we have and we use, because some of these things aren't really an exact science, so to speak. So yeah, so basically I want to become better, and I hope that you guys can help us along that way. So a bit about myself. My name is Magnus Stubman. I'm a pen tester / red teamer at InProsec. I started out as, I've always been interested in hacking and IT security since I've been a kid. And I studied to become a software developer. So I actually started my career as a software developer. And then later on got a trainee position, so to speak, at a cybersecurity consultancy, which was really beneficial, I think. So if anyone has been in a similar position, I'd really suggest going that route, having like a training position, so to speak. Yeah, so on to phishing. So with phishing, you're trying to do either one of 2 things or maybe both. But today we'll split them up just to make it more simple. So I guess the classical phishing approach was about stealing credentials, credential theft, meaning enticing your victim into giving you their username and password, typically by giving them a link to click to, where they have to click login and enter the credentials, which instead of being sent to the real login page would be sent to you. That's the classical, right? And the second approach is about getting your malware to execute in a target environment. And that's what I want to focus on today. And of course, I would really like for you guys to just send your questions, and Joff or Andrada will just interrupt me and ask the questions. So don't wait until the end. Just bring them when you have them. So credential theft, as I just mentioned, I'm not going to focus too much about that today. But credential theft, getting usernames and passwords, is really nice if you have two conditions. You need to be able to use them in some way that will actually allow you to continue against gaining your trophy, so to speak. So that means, for example, that there should be some kind of internet exposed, maybe Citrix or VPN or similar, that doesn't have two-factor or multi-factor authentication. Because then you would have to bypass that, of course. And obviously, there are also ways to do that, but that's a bit more challenging, I guess. So you would like to steal creds if you can use them to get access directly. For example, via VPN or Citrix, or access to vSphere, FTP, or if you can access some employees' mail accounts directly from the internet. Doing so might allow you to do internal phishing, which has a huge advantage since it's really hard to tell that it's actually malicious for the recipient. But in my experience, doing typical classical credential theft via phishing isn't really that necessary today, because many organizations allow what we call external horizontal password spraying. So even if organizations have two-factor authentication, you can usually use some kind of external authentication interface to distinguish between a correct username and password guess and an incorrect username and password guess. Because usually, let's say if they have two-factor, if you guessed the correct password, then typically you will be prompted for the second factor. But if you guess the wrong password, you wouldn't be prompted. So in that sense, you can typically use even 2FA authentication interfaces as a kind of an oracle to ask, is this the right password? Yes, no. Yeah, so therefore, I don't really think that in the most use cases it would be beneficial to do like old school classic phishing to get passwords. So hence the focus on malware execution today. So if we take a look at a standard payload, for example, the standard macro that Cobalt Strike generates when you just generate a standard word macro with Cobalt Strike, usually you get something like this. So obviously there are some things that I cut out here just to make it more readable, but you have your shell code. That's basically the actual malware. Then some detection to see what kind of operating system you're on. It spawns a process, allocates some memory, writes the malware, the Cobalt Strike beacon, and then spawns a thread. So this is basically process injection. Yeah, so that's the standard kind of standard that Cobalt Strikes give you these days. So basically, when you do that, you go from Word directly to Cobalt Strike. So you go directly from your like medium of delivery directly to your malware, and that might seem great because it's simple and off you go, but it has some disadvantages that we're going to talk a bit about today. Because what do you do when you click send and then nothing happens? It can be really frustrating because should you wait longer? Should you try again? Can you send the malware again? What exactly are you going to do? It can be a bit nerve-wracking if you don't know exactly why you didn't get your shell, so to speak. Was it some kind of maybe some email scanning products? Was there any kind of sandboxes that analyzed your payload and determined that it was bad? Maybe the user was suspicious. maybe the antivirus or Endpoint Detection and Response, EDR, caught it. Well, if you don't plan for these situations, then you're never going to know. You're just not going to get a shell. So that's the kind of the topic of this phishing talk today. Yeah, as I said, if you don't know, you will get burned. So preparation, reconnaissance, doing your homework. So the classical techniques that we're not going to go into in depth about today is obviously OSINT reconnaissance. So LinkedIn, typically a gold mine, searching for your target company and then searching for some kind of AV products. Usually gives you some profiles of some security employees who loves to tell the world about what kind of products they have and so forth, which is really beneficial for you as an attacker. We're also seeing Instagram actually being a great place for open source intelligence recon. Starting out by search. Usually companies have a presence on Instagram. Usually finding those pages, showing some of the, and then looking through some of the likes that the images have. Usually we'll find, if you're a bit lucky and spend a bit of time, you'll find employees who liked some of the images. And then just by going to their profile, usually if you're lucky, you will find a photo or two of employees like taking a picture of their coffee cup right in front of their screen at work. And then in the corner, you might be lucky and see tray icons that will kind of tell you which AV or EDR is installed on the machine. And then, of course, there's also Googling as well, plain old simple Google. But there's also more active approaches to doing reconnaissance. And one of these techniques is what we call preliminary phishing. So preliminary phishing is not really phishing in that sense, because we're not trying to steal passwords. We're not trying to execute malware. All we're trying to do is to basically get an answer and see if we can get some kind of information out of it. So if we add a tracking pixel or a so-called heartbeat image, which is basically just an HTML tag with an image tag pointing to an URL on your infrastructure, then in your access log you will obviously get you'll see what kind of what IP your target came from, if the image was rendered, which is a good indicator of their external IP, obviously. And if they reply on your email, in the email headers, if you're lucky, you'll also see the internal domain names of the internal email systems. The internal host names of the internal email systems that sent the email from the organization, and those usually include the AD domain name, which is really nice, because doing that you can use that as environmental keys. So you can use the external IP address and domain name as environmental keys, and you can also use other things. This is just a couple of examples. So what's environmental keying? Environmental keying is about ensuring that your malware, your payload, can only execute exactly where you want to be able to execute. So the way you do it is that you program your malware such that it can only decrypt itself if certain keys are present that you know is only going to be present in your target environment. For example, the external IP or the domain name. So it's pretty simple. Step 1, get the external IP or domain name. Step 2, use it as an encryption key to decrypt your malware. Then obviously you have to program this so it happens on the fly. So a bit of pseudocode. So step 1, get the external IP address, save it as an encryption key, and then you have your encrypted malware. And then you decrypt your encrypted malware with the encryption key. And if that works, that means then you're actually on the right target system. If you're in a sandbox, or if you by mistake sent your phishing email to someone else. Obviously, that shouldn't happen. But if you're not in the exact right environment where you want to be, the decryption key will be wrong, since it won't have the right external IP address, or it won't be the right domain name, and therefore it won't be able to decrypt, and therefore it won't be able to execute either. So this is actually a really strong technique to ensure that, to make it more hard for the defenders to catch your malware. So that's great. So that just leaves us with suspicious users, maybe not running on malware, or maybe even reporting it, firing up a case, or the antivirus and the endpoint detection and response kicking in. So that's what we're going to look a bit about. So to look into that and kind of become smarter about what's going on and why, we'll look at adding heartbeats, or pings, if you will. So this is just about ensuring that you get a notification if for each step of malware delivery, so to speak. So what we want to know is that we want to know, did the user read the email? That could be a heartbeat. Did the user click the link in the email to our email to our malware? And if they click the link, did they actually open the document, assuming we're sending a Word document? And then step number 4, did they actually enable macros? So what we want to do, our goal here is to have mechanisms for each of these steps that gives us a notification if they happened. Because then if we get notification 1 and 2, then we'll know what went wrong. We'll just know that the user didn't open the email. And that will make us smarter and better prepared in preparing our next wave of phishing emails. So step 1, did the user read the email? Just as before, we can add the HTML image tag that will try to render an image from our attacker-controlled server. And again, we'll see in our access log if that happened, as we'll see the specific URL being loaded. So did the user click the link? This might seem trivial, but of course we'll know, because the access log will show us that the file was downloaded. And what we can add here is some kind of special unique ID to each payload link, so to speak, so that we'll know exactly which target employee that clicked downloaded the file. And the third trigger that we want to get is whether or not the user actually opened the document. Because if it was downloaded and not opened, it could mean that the user was suspicious, or it could mean that the antivirus ate the file, or that some kind of inbound download inspection product analyzed it and determined it to be bad. So the way we can do that is with, obviously it depends on what kind of payload you're hosting and trying to use. But I guess the most popular one is using Office products like Word. And what we can do here is we can add an external image, so to speak. You can do that actually by just clicking Insert Picture, and then instead of adding a file name, you just add a URL. And then in the dropdown, you select Link to File or Insert and Link. Because if we do that, it will try to load the, it will show the image, obviously, which it will load from our attacker-controlled host. So if we fire up Wireshark while we create our malware, we'll see that it will try to download the image from the URL that we added. And this is going to happen regardless of macros being enabled or not, as far as I'm aware.
Hey, Magnus?
Yeah.
I have a question from the audience.
Yeah.
Maybe a bad question, but how is this different from canary tokens, and which is better or worse?
So canary tokens, I guess, are a bit different, because you use canary tokens to detect attackers who are already in your environment when you add them to your for example, your Office documents or the file types to catch and detect attackers who are already present in your environment. So I guess it's quite similar to that, but there's a different goal here. We're trying to detect if our phishing is successful and how successful it is. So I guess it's quite similar in that sense. It's just kind of different purpose. But good question.
For the host to see if he understands it. So it's basically different use cases for the two of them.
Yeah, absolutely.
Okay.
For canary tokens, detecting attackers who are already inside, and here we're kind of doing a bit of the same, but with an offensive purpose.
Great, thanks. I hope that answered the question from Michael.
Sorry, I didn't catch that.
I just said thanks.
Yeah, okay, yeah. So, and the fourth step that I want to know is that we actually want to know if the user triggered and enabled the macro. Because at least in my experience, this is where people get a bit suspicious if a document wants to enable macros for some reason. So if that happens, we want to know when the macro is enabled. And this might seem a bit odd, because if our macro is enabled, then our malware will execute, right? So then we will get a shell, so we will know in that way, right? But it might actually be the case that the users click enable macro, and then something actually goes wrong, either that AV or EDR blocks our malware, or that it could be something trivial as just us making a bug. It might just be that our malware doesn't, just plain old simple, it doesn't work properly in the target environment for some reason. And if that's the case, we want to know. So before a malware executes, but right after the macro is enabled, we can add a macro like this that will programmatically insert an external image when the macro is enabled. Again, this will give us an indication that the macro was enabled. And again, we can see it if we debug it with Wireshark, and we'll get an entry in our access log. So we'll know. So these techniques that I've talked about can help us detect if exactly what went wrong down the road of trying to successfully phish a target employee. We'll know if it was the scanning product, say sandbox, or suspicious users probably. But the AV, the EDR is a bit special, and I guess for many assignments, it could be the worst, so to speak, depending on the target environment, of course. So how do we actually reduce the chance of our product, of our malware being caught by the AV or the EDR? So the best thing that we can do to that is, of course, to test it offline. But there's some problems that comes along with that. The first one is obviously which AV EDR they're using. Again, we talked a bit about OSINT Recon before. That might give us some hints or some clues, but it's still a challenge that we need to address, because it's just silly trying to bypass the wrong EV and then ending up getting caught anyway. One way we could go about getting a hold of the AV, if we know which AV or EDR it is to just ask for a trial version. So this has become increasingly hard, because the AV EDR vendors know that people who have an offensive goal use this technique to test it offline. There's also the option of pirating it. Obviously, that's illegal, so it's a bad way to go. But it's also a way that will probably give you the wrong AV or the wrong EDR product, because getting the exact right version or newest version, or getting the cloud analytics, which are usually very important, doesn't come with the pirated software either. So at least 3 bad reasons for not pirating it. And the fourth option is just buying it, right? And it might seem that's the go-to, but buying EDR products, with AV products it can be straightforward, but buying EDR products these days can be problematic, because the vendors obviously know that people with an offensive goal are willing to spend money on just getting a hold of it. So usually you have to buy a certain volume, for example, 1,000 licenses, or they need to vet you somehow and see that you are a legitimate company and you have a legitimate need of it, and so forth. So it can actually be quite hard to even buy it. For the criminals, there's also the option of hacking some other company that they know have it, so that they can like test it in some other environment where it's not really that sensitive for them to get burned. But for me, the consultant who work legally, that's obviously not always a solution.
We have another question, Magnus.
Yeah.
So this one comes from Kettle, and I apologize if I mispronounce your name. Hey Magnus, what is your opinion on Net-NTLM relaying to exchange via UNC links in phishing mails, and generally organizations not blocking outbound 135, 445, enabling credential exfiltration over the internet? Yeah,
I think it's a great attack. I think there are two problems with it. For the first, obviously, as you addressed yourself, is that usually the ports that you need to be able to use this outbound are typically blocked. At least that's my experience. And if they're blocked, they're kind of game over, right? But the second problem is that I haven't exactly used this technique in a while, but if I'm not mistaken, then it requires for Windows to willingly submit Net-NTLM hashes to the internet. It needs to be kind of configured wrong with the zones. So as far as I'm aware, this attack works best if you're already on the LAN. So it works more. I think it works better as a privilege escalation technique or lateral movement technique if you're already on the environment, so to speak. But it's definitely an interesting idea, and I'm sure that there is some value to be found by doing more research into this area. I think it was MDSec who did a good amount of research into this topic, but for the LAN environment, who created a pretty nice tool, which unfortunately I haven't added in my presentation today, but we can share that later if you're interested. But a good question. So, the kind of tactic or procedure that we came up with is about making it okay that our malware gets burned. Because let's just realize it, making payloads for phishing can be quite challenging unless you have an easy target, so to speak. And you have to just realize that you will get burned, at least to begin with, at some point. At least that should be your assumption, right? There's nothing worse than spending a lot of time making like your perfect malware that just should be super, super nice. And then for some reason, you don't get a shell and you don't know why. Because in that case, it could be the case that your malware got busted or something else and it's basically burned, right? So instead we came up with this approach of so-called flammable phishing to make it okay that our malware get burned. And the underlying principle is quite simple, I'd say, because it's all about instead of spending a lot of time making really slick, fancy payloads, it's about making cheap, discount, throwaway payloads that are fast to create. And these payloads can't be really advanced, because if they're advanced, it's going to take a lot of time to create them. But they should just do two things, actually. The first thing is to give us an understanding of what software is installed in the target environment. So it should do a bit of host reconnaissance. So what we want to know is what AV in EDR is installed, what third-party apps are installed, what kind of hardening is present on the system, etc. And then take that information and upload it to our command and control host, so we can analyze it and prepare our next step. So that's the first thing this flammable phishing payload should do. The second thing it should do is that if this was actually executed, then we don't want to drop our execution, so to speak. We don't want to waste it or let it go to waste knowingly. So step 2 should be that it should periodically attempt to download and execute something from our C2 server. So this doesn't necessarily have to be download an executable, write it to disk, and execute it. It could basically be anything that will allow us to deploy other malware, other software on the target host. So the benefits to this approach is the first one is, of course, it's cheap. It doesn't take really much time to develop these kinds of payloads, and that has the super nice quality that it makes it okay if it gets burned, because if it gets burned, we'll just make another one, right? The second great quality is it will tell us what defense solutions that are in place, which will enable us to bypass it offline. And also, as an added extra benefit, is that let's say that we see that they have some specific third-party software that we either have a zero day for, or we think we'll be able to find a zero day for, then we can actually prepare that offline so that we have an exploit working for exactly that version of third-party software, so that we can escalate privilege locally quickly when we land, and then move on from there. And lastly, it has the benefit that we can actually wait and deploy our real malware when we know we are ready. So phishing in this manner will become less scary, because if it gets burned, doesn't matter. We'll just make a new one and try again, basically. So we won't have to be as careful and as afraid as an attacker. And this might even mean that we can maybe just skip the preliminary phishing entirely, or if we're really courageous, then just skip the OSINT recon entirely as well. Obviously, I don't think that's a good idea, but if you have enough of these throwaway payloads, then it might be the correct approach. So diving deeper into this strategy, there's a bit of terminology that I'd like to put in place. This is the stages, like stage 0, stage 1, and stage 2. So the stage 0 is basically just our method of getting execution. It's also sometimes called loader, and I guess also maybe by some people called a dropper. And all it does is it allows us to execute something. So a stage 0 could be, for example, a Word document. It could be a shortcut, LNK file. It could be an HTML application, as they're called. It could be JS files, SLK, and so forth. There's quite a lot of stage 0 payload formats out there, I guess. And there's still going on a lot of research into finding new exotic ones that no one has seen before. So that's the stage 0. Stage 1 is the first malware. It's just basic malware that just give us just the basic capabilities we need, and maybe also gives us persistence. So this could be, for example, the throwback malware made by Silent Break Security, or it could be something else that's really, really simple, homemade, custom tailor made, that just allows us to execute basic commands. And then stage 2, this would be the real deal. This would be the fully operational malware that we need to have to actually pursue our goals or our mission objectives, and get our trophies, so to speak. So this could be more advanced malware, for example, Cobalt Strike, Slingshot, whatever you have, ParseC2, Puppy, something that's a bit more advanced and enables you to pursue your goals. So if we go back to the phishing payload example that I showed you to begin with, the default Cobalt Strike macro, as I explained, it goes straight from the Word document to a running Cobalt Strike beacon, right? So if we apply this terminology of stages, that would mean going directly from stage 0 to stage 2, because Cobalt Strike is quite advanced, and it's a fully featured, fully operational malware that allows us to do a lot of things. So in flammable phishing, so to speak, instead, it could be like this. It could be, for example, stage 0 and stage 1 in one file, an HTA file that, for example, enumerates installed software and sends that back to the C2. And then after that, just periodically waits for a command to execute. So this is an example of a flammable phish, so to speak, that I developed. I think it took less than an hour to create. It's publicly available here. I'm not going to go over all of it now, but I'll just show you a demo instead. So on the left, you have just a really simple HTTP server, just a default Python simple HTTP server running in our attacker host or C2 host, so to speak. And on the right, you have our simulated target host, our victim machine. So assuming the victim already downloaded our payload, and now the victim is going to execute it. So the victim runs our payload. And now in the background, you'll see that this flammable phish starts exfiltrating some data. And we'll skip a bit ahead because this takes quite some time. And so now it's done, right? Now it started querying for index instead. So let's take some of this data and decode it, because this is just base 64. And we'll see here that in this example, it just told us that Citrix is installed, Citrix Authentication Manager. So in this video, I don't go through all of it, but obviously it's a list of all software installed, and hopefully in a live environment, it would include our the EDR product or the AV that's present on the target host. So let's now assume that now we have prepared our stage 2 malware. Now we know exactly how to bypass whatever security products that we learned is on the host. So what we would do now is that we will give some command to our flammable phish, so to speak. So we'll edit the index.html file and give it some command. In this case, it's just telling it to show a message box. We'll save that and start our HTTP server again. And we'll see that our malware successfully executed the command. Another example could be to use Windows shortcuts, for example, LNK files, with a PowerShell download cradle. The stage 1 could be just to down execute some simple enumeration PowerShell, and then stage 2 will be able to load some second stage, more advanced malware. A third example could be to use Word. For example, with .NET.js to spawn some stage 1, which could be, for example, the throwback malware by Silent Break Security, which then could use shellcode reflected DLL injection to spawn some second stage malware, Slingshot, Cold Strike, etc. So this is just some examples, just to inspire a bit. So the moral of the story: if you don't know what went wrong, you can't fix it. You need to know exactly what failed. Otherwise, you won't be able to progress. Otherwise, you're just shooting in the dark. And at least, based on my experience, phishing will usually fail in some way. And if you make discount malware, it won't hurt as much when it burns. So that's my kind of takeaway from this. And I guess that concludes my first talk for tonight. I think we'll have a 5-minute break, so I guess we'll continue at 8:45, and we'll continue with user node API hooks and bypasses.
Thank you very much, man.
All right, I guess it's time to get started.
Hey, Magnus. We had 2 questions come in during the break.
Yeah.
So I hope that you can talk for a minute or 2 about them.
Yeah.
The first one is from People. Hey, Magnus. Base 64 makes suricata or snort go wild. What are your thoughts or ideas on more esoteric transport channels besides the classics like DNS, hiding stuff on cdns, etc.?
Yeah, I think I mean.
Sorry.
Yeah. It's a really good question, and I don't think there's any right or wrong answers on this. But I mean, the idea from this approach is to make something that's fast to implement and fast to send away. So if we have to spend more time making it a bit more, implementing other things like encryption or whatever you want, or steganography, obviously that's going to take more time. And there's no, like when we're this early in the phishing process, we don't know why, if that effort will be worth our time, right? So we would rather just try something that's cheap, and it might be more noisy, but we'd rather just send it and then realize it didn't work and then develop the more advanced stuff. So specific regarding like using DNS or ICMP or other out of bounds channels, I think the more you try to like hide or like do other things, it can actually be a bit of a, it can actually be like a giveaway that you're trying to hide. For example, if you use encryption, some products will use like a statistical analysis to detect that this piece of code is actually encrypted, and having like encryption in the URL or whatever is actually might seem suspicious for that reason. So obviously base64 it might not be the best answer always, but yeah, I'm sorry, I don't have any. I can't tell you like this is the perfect way to do it, because I guess it changes. It depends on the environment. So I guess the best answer that I can give you is that like experiment, do what's cheap first, and then improvise and innovate as you go along. But it's definitely a good question, and it's one of those things that you spend a lot of time thinking about, I guess, especially during engagement.
All right, thank you for that. The other question we had was, wouldn't most of the mentioned file types get caught by enterprise-grade scanners, such as Cisco IronPort?
Yeah, I guess, but that's also a bit. The point isn't to get caught, but the point is to do something that's fast, right? And there are other tricks as well. For example, you can use docx files that can't have macros, but then you can add like an external template, which can be a template, like a macro-enabled template, so you can introduce macros that way. But of course, this is exactly the race between the cat and the mouse, right? It's the offensive people innovating and bypassing the security products, and then the defensive solutions detecting it and following it along. So it's the never-ending cycle, right? So of course, the well-known samples will probably get caught, but again, you can't always block everything. There will be things that even good products just miss. We have been surprised a couple of times, simple things that good products miss. And that's also the thing about luck, right? Because if you assume that you're up against the best, most hardcore product, it's going to detect all the default cheap go-to things. And therefore, you assume that that's the case, then you're not going to try it, right? But then maybe if you try it anyway, then you actually might be lucky that your specific payload is actually missed somehow. Maybe there was some kind of what do I know? Maybe it was lack of resources, and that exact time. It might be that there was too many emails, so it couldn't scan them all at the same time, so it just let it through anyway. Or there was, and this specific organization maybe had whitelisted that exact file format because they decided to do that, or some admin made some mistake. There might be things that I mean, you're not going to get lucky unless you try your luck, right? And using the cheap things are cheap, so why not do it? I guess that's the principle that we try to pursue.
Great, thanks for that.
And also really good questions. Just keep them coming. And also, if you have any, we're obviously going to go away from phishing now a bit, but if you have any phishing ideas or thoughts that come up, just please just send them, and we'll take them anyway, right? But now we'll go into the next phase of an attack, so to speak. Now we're assuming that we're already on a host, we're already landed in our target environment, and we're seeking to do our malicious acts in a way that is undetected from the EDR product. So we want to fly under the radar, so to speak. I'm still me. So I guess we'll look a bit about why defensive is is useful and in what situations this might apply. And then we'll make some probably oversimplification about the Windows architecture. We'll take a look at how memory works on Windows, and take a look at how Win APIs work, a bit of a one-on-one there. And then we'll introduce what a hook looks like. And then last, we'll look in some different bypass techniques, and I'll show one specific technique that I implemented. And again, just keep the questions coming if you have any as we go along. So obviously, the goal of security products is to have kind of complete surveillance of what happens on the host. So they want to know everything that's going on the processor, right? And that's great. But if you're an attacker, not so much, because a core realization, a core truth about being the attacker is that if the target organization knows that we're there, then they're gonna kick us out, right? Or at least they will try to do it, maybe not right now, but they will at least make a plan for kicking us out or stopping us, right? So we can't achieve our goals without stealth. So we have to remain undetected to be able to get our trophies. So if we take maybe a trivial example like Notepad. So Notepad obviously writes files, right? That's what it's for. So when you launch Notepad, you add some text and you hit save. It's going to try to write some content to disk. And this could be a thing that an EDR product would be interested in knowing. Obviously, writing files to disk will be not really the best example, because the disk gets so many writes all the time, so it might be too bit noisy. But for this example, it works great, I think. So writing something to disk, Notepad needs to tell the operating system that it needs to write something to a file. And to do that, it uses the standardized function, for example, the write file Win32 API function. So you just give it some data and tell it where to write, and you call write file, and the operating system will write the data to disk. And obviously, the Notepad can't just write it itself. It can't just open the disk and start writing bytes, because then we wouldn't really have a secure operating system if any process could do whatever it wants in the environment. So therefore, Microsoft introduced the kind of split between low privileged processes in user mode, and then everything else that's special and can't break and should be resilient in kernel mode. So the way that processes tell the operating system to do what they want it to do is by having this intermediate layer, the Windows API, or also as is known, the Win32 API, as we just saw with Notepad's write file call. So, but let's take a step back and look a bit about how it looks in the real world, because you have the executable file Notepad on disk, but it looks a bit different when it's actually running in memory, right? So that's what we're going to explore a bit to kind of set the stage for API hooks. So obviously you spawn Notepad, and the process is spawned in user mode, and the process includes many things, but we'll simplify it quite a lot. But one of the first things it has is obviously the code from the executable file, and it will also have a lot of code from a lot of libraries, many different libraries, and this is actually where the Win32 API is. It's actually just a bunch of libraries being loaded by processes, which is loaded inside the process. So the process contains the libraries in some sense, I guess. Again, we're oversimplifying it because it's really quite advanced. So in Notepad's code from the executable, it will call the write file function, and the write file API. And when you call that, what you're basically calling is you're calling a function inside some library, and that library obviously needs to call the operating system, to call the kernel and tell it that this and this process wants to write this and this data to this file. And this is great, right? And this is exactly where EDR products, at least historically, has been known to to want to add their monitoring mechanism, to add their hook, so to speak. Because if they can monitor the loaded libraries inside processes, then they can know what's going on, because they will know all the calls, right? At least that's the idea behind it. So if we go back to the write file function, and go a bit down on the same page, we'll see that the library in question here is kernel32.dll. And if we explore a bit about what libraries that Notepad has loaded, here I'm using Process Hacker to browse the modules of Notepad. We'll see that kernel32.dll has been loaded. And if we double click on that, Kernel Hacker will show us what functions that reside in kernel32.dll. And here we see write file. So this tells us that Notepad has loaded the right library, and it now has the functionality available to it inside its own process, so to speak. So Notepad is great, but it might not be the most exciting hacking activity to perform when you're trying to compromise an organization. Instead, we'll talk a bit about Mimikatz. And Mimikatz, it's a tool that can do many things, but I guess it's most known for its ability to perform credential theft or credential dumping, which is one of the core activities, and also one of the things that we use it for the most. So a bit about background about how that works. We'll dig into how Windows handles sessions and credentials in memory. So Windows has this service that's called the Local Security Authority Subsystem Service, LSAS, and that stores credentials in memory on behalf of the users that use the host. And as we can see, there are many different types of credentials. It could be reversibly encrypted plain text passwords, could be Kerberos tickets, and it could be NTLM hashes. And this happens actually quite a lot, because as we see, LSA sessions with stored LSA credentials are created when a user does any of the following. So for example, logs on locally, or RDPs and starts a session on the host, or any of the other thing. But I guess for most organizations, at least as an attacker, this is what happens most, or the local sessions, of course. So that's most interesting. So this means that inside this process, LSAS here, inside this memory here, will be juicy credentials and passwords and NTLM hashes, hopefully, that we want to achieve, right? And that's exactly what Mimikatz does. When we spawn Mimikatz, enter a couple of commands, it's going to dump the username. In this example, the username is user, and show us the NTLM hash of that user. And if we're a bit lucky, we'll also see some clear text passwords. In this case, no, but at least the NTLM hash is pretty great, as we can crack it, right? Or we can pass it in many instances as well, or overpass it.
We've got a question again, Magnus.
Yeah.
Sorry to interrupt. So, do you have any suggestions to avoid AV execution and AV execution emulator, similar to calling virtual alloc x numa in an execution wrapper, which would usually not be included in an emulator environment?
No, I don't have any suggestions for that. I haven't looked into that specifically. Sorry.
Okay. Thank you.
But if we again take a look at Mimikatz running, we explore it with Process Hacker, we'll see that Mimikatz has loaded the library ntdll.dll, and inside ntdll we'll see that there's the function called nt-read virtual memory. And this is a special function because it allows processes, if you're suitably privileged, it allows them to read memory of other processes. And this is exactly what Mimikatz or similar software does to extract the NTLM hashes or passwords from LSAS. So how does this corresponds to hooks? For example, if we start by taking a look at the DLL on disk, we grab ntdll.dll, and then we disassemble it with, for example, Ghidra or IDA Pro. If we then navigate to the nt-read virtual memory function, by searching here, GitHub will show it to us. And the opcodes, so the instructions, are these ones right here, right? So this is exactly what it does. It moves some data around, it performs a test, conditional jump, and then it does a syscall to the kernel to actually read the data from the target process. So this is what it should look like. But if let's say that we have our malicious process now running in memory, we launched it, and then we start debugging it a bit. When we attach with WinDBG, Windows Debug will show us all the modules that loaded for the process. So in this case, there's also a DLL loaded that I have chosen to censor out. So this was actually the DLL from the EDR product or the EV product. The reason I chose to censor it was because it will give away the name of the product, and that's kind of beside the point of this talk. And I don't want to hang out any specific. I don't want to like point any fingers anywhere, because there are different reasons for that, right? But we can see that there's been some kind of DLL loaded, right? So something funky is going on here. If we then give it,
Magnus.
yeah.
Sorry to interrupt you again.
Sure.
We have a question from the audience from Lhasa. Wouldn't Mimikatz always be caught by AV or EDR, or are you I can't say the word right now, hiding Mimikatz in a special way to evade such detection? It's late. Sorry.
Yeah. Yes and no. There are different ways to be able to do the things that Mimikatz do. Obfuscating Mimikatz is one way, because the source code is available on GitHub, right? So you can download it, obfuscate it however you like, and then compile your own version. There's also a great number of tricks to hide it. For example, executing it in memory will fool some AV products, and there are different ways to do it. So in this setting, we're assuming that we already have that covered, right? We're assuming that we can run the tool. It's just the behavior that will get caught by hooks. So what we're doing here is that we're pressing U space and then nt-read virtual memory, and this will show us the actual bytes of the function as it's loaded in memory. And as we see on the first line, what it should be, it should actually be 2 moves, 1 test, a conditional jump, and a syscall and a ret, right? But instead, there's a jump, and then something weird after that. So what's going on here? And if we look into that memory where the jump takes us, we'll see that there's some more code doing something that we haven't exactly determined at this point. And if we set a breakpoint in nt-read virtual memory and take it, we'll see that the jump is taken. So what this tells us is that something or someone is diverting our execution flow away from the real nt-read virtual memory function somewhere else, right? So that's a hook. That's someone else being able to monitor what we're doing or stopping us by either not returning us back to the real function, or just monitoring it and returning our execution back to the real function. Yeah. So what do? We still want to dump credentials, but how do we do that if we're monitored in this way? So there's some different strategies or tactics you can pursue. The first one could be, for example, to overwrite the hook. Just write the correct bytes, write the real opcodes, and remove the hook. That's relatively simple, relatively straightforward, and it's pretty stable, as it ensures that all functions that call nt-read virtual memory will benefit, right? Because anyone calling the function will get the right bytes, so to speak, the right opcodes. The cons is that you need to be sure that you do it OS version specific, because different versions of Windows has different implementations of nt-read virtual memory, and if you screw that up, it's not going to work, or your application might crash. Another thing that's bad about this approach is that it could actually be a giveaway to the security products, because they might monitor their hooks, so they might actually detect that you violated it, and somehow they might detect that you overwrote it. And if you want to look at some examples, Outflank has made the dumper tool, which is quite great, and Silence has made the reflective delay refresher as well, which is a bit more advanced. And then another tactic would be to overwrite the entire module, so overwriting the entire library as it is loaded in memory. And this is basically more simple, because you don't have to think about which exact bytes. You don't have to worry about is it hooked or not. You just overwrite the entire thing, right? And this is great because it ensures that all functions will benefit. And also you can be sure that you have unhooked everything there is, right? Because you're just overwriting the entire module. The cons, again, is that security products can detect the integrity violations, and it's a bit more noisy than just overwriting the specific bytes in the other example I showed you. And there's an example from iRed team here, if you want to take a look at that. And then there's a kind of exotic technique you can use, basically going around the hook. So this technique is pretty advanced. It requires that you, at runtime, you can detect the hook and then find out where is the real function located, find it, and then just jump to that instead. So this technique is known as the firewalker technique. And the reason it's great is that it works on most, if not all, OS versions. And the original hooks are left in place, meaning that defensive products can't see that you removed the hook, because you didn't. You left it where it is. Instead, you just jump around it when you call the function. The cons is that it's a significant slowdown, as you need to trace and do a lot of computations to figure out exactly where things are. So it's going to slow you down significantly. And it's also pretty complex to implement. MDSec came up with this technique, and they have a great blog post detailing exactly the benefits and pros and cons about it. And then there's the technique that I chose to go with, just basically bring your own function or bring your own code. So basically, it's just don't call NTLM virtual memory. Call your own function instead. Some of the good things about this is that it ensures that the hooks are left in place. So detective tools can't detect that you unhooked the function because you didn't. The hook is still there in the original function. You're just calling your own function that does the same. The bad things, of course, is that it's OS version specific again. So you have to be sure that you know that you're using the right function for the specific build of Windows that you're on. And also, only your own code will benefit. So if there are other functions inside your process that calls NTLM virtual memory, then those won't really benefit. And I have implemented that in my own version of Mimikatz, just to experiment with that. So basically, it should look like this, right? Move, test, conditional jump, syscall, ret. So starting with 4C, 8B, D1, and ending with 0F, 05, C3, right? So what I did was that I copied all these opcodes here, shown here, put them into an array, I then allocate some memory that's executable, and then I move my opcodes to that executable memory, and then make a function pointer that I point to that piece of memory. So this is the way that I kind of created my own NTLM virtual memory function. And I implemented that in my own version of Mimikatz, which was pretty fun to do, quite challenging but pretty fun, and it ended up working on that specific build of Windows. So that this was one way of circumventing user mode API hooks. So I guess to conclude, security products should rely on user mode API hooks as a security mechanism, because as we have seen, the APIs are in a sense owned by the process that loads the API, so it's trivial to mess with them. Instead, security mechanisms should be implemented in a privileged context, such as, for example, the kernel, in kernel mode with maybe with drivers or so forth. But really, that doesn't solve all problems either. As an attacker, you could load malicious drivers and try to remove kernel callbacks and so forth. So I guess there's no easy solution for the AV vendors, but at least user mode API hooks shouldn't be used by themselves as a mechanism, I guess. And I guess that was it from me from this talk.
Great, because we have a question. One is, can you risk killing the operating system when the kernel call is made?
I guess so. I guess so. If you don't careful about what you're doing, if you call the wrong, make the wrong syscall, it might crash. It might give some exceptions at least. So you have to know what you're doing, obviously.
Great. If there's any other further questions for Magnus, please post them now. I'll wait a few seconds. There has also been a request about uploading the slides or creating a PDF of the slides. And as far as I recall, we are going to share a link to the slides later on. So that will be available to everybody who's listening right now. Yeah,
so the slides are available on these URLs, and we'll make it online, right? Obviously.
Yep. One other thing, maybe for someone like myself who doesn't know about how you get into the field, do you have some suggestions for people who might be interested but are quite new to the field on how to get started, self-education or training or stuff like that?
Yeah, I would definitely. I would start out by just like googling like silly questions like how to hack. Like just googling whatever comes up to your mind, because you will find the internet today is just so filled with so many great resources. You can even learn some techniques from YouTube, right? So I think that would be a good way to just start. Just ask the questions that you have that you might feel. That you might not want to ask to sound dumb, just Google them, and you might, and you probably get some good resources. And I think the other tip I would give is just, at least that has benefited me a great deal. I think is that I tend to be less afraid of asking stupid questions. I would rather ask and then get told that's a stupid question and so forth. So I think people should be good at reaching out, be good at asking questions. Reach out on whatever medium you have. There are some great communities and forums and chats and Slack and whatever, Twitter, with some really skilled people who would love to help. So I mean, there's very, very few things that most people come up with, and we're basically all just standing on the shoulders of giants, basically. So I think there should be no shame in just asking questions.
Do you, as a follow-up to that, are there people in the field who mentor, younger hackers or people who want to get involved in the field but either don't know how or kind of intimidated by the field?
Yeah, I guess I do. I have been mentoring some people as well, and I'm pretty sure others as well. And I think the best way is just to reach out and ask, and also, as I mentioned to begin with. Getting like a trainee position at a company could be really beneficial, because security companies are struggling to find senior consultants. So what they do instead is typically to hire younger people who seem to have a talent for it. So if you can market yourself in a bit that just shows that you have a passion for doing it, that could be maybe creating your own blog or pushing some code to GitHub to show that you care. And it doesn't have to be advanced stuff. It could be like a wrapper script for Nmap or whatever, something maybe not silly, but something simple but solves a problem that you had. It doesn't have to be a problem that everyone has, But if you can show that you solved a problem that you thought was a bit annoying and you could automate maybe quite a bit or just a slight bit, then that really shows that you're interested in it and willing to investigate and experiment. And I think that's what's one of the key things that shows recruiters that you're willing to and interested and have a passion for the field. So that would probably be my tips.
Okay, thanks for that additional information. There's a lot of people to thank on this. First of all, Magnus, for being a superhero, for doing not one, but two in one night. We really appreciate that. So I'd like to thank you from everybody from OWASP Copenhagen chapter. Thank you. Also to everyone who's listening right now for participating. We really appreciate it. Thank you for coming out. Please join OWASP. Please spread the word. We're looking for more people like yourselves to come in and join us. Please volunteer if you have the opportunity to. I also have to thank Dakota. He's the guy who's taking care of all the video and making sure that you can actually see what's going on here on YouTube. And of course, Andrada and Josefina for all their assistance with the questions. It really is a team effort to make these things happen. And thank you for that. We're also going to post a link to our Jitsi if you want to have a short chat with any of us or with Magnus afterwards. So please join us there. And for everybody, thank you and be safe.
Thanks.